Hello everyone. Today we are going to study Rolle's and mean value theorem. First I'm going to begin with the Rolle's theorem. Now Rolle's theorem states that if a function is continuous on a closed interval and differentiable on an open interval, say a to b, the third condition that if the function at the endpoint a is the same as the function at the other endpoint, say b, then there is at least one number c in the open interval a to b such that f prime of c is 0. That is, the derivative at that point c is 0. So let's look at an example of how a function where the Rolle theorem is applicable. So this first one is a graph of a function which is basically an upside down parabola, which is a graph of a quadratic equation. So when you look at this one, clearly you see the function is continuous, it is differentiable in the interval a to b. Also, the endpoints, the function value at a is the same as the function value at b. So Rolle's theorem's conditions are applicable, and hence there will exist a point c and at least one c over here such that the function derivative is 0. So clearly this is the one which conveys the fact that f prime of c is 0. Now let's look at an example where the Rolle theorem is not applicable. So in this example, notice the function is continuous. The function at endpoints are the same, but the function is not differentiable. If you recall from your differential class that this is a sharp point. So this is where the function fx is not differentiable because of a sharp point. Thus, Rolle's theorem is not applicable. Let's look at more examples. Now here the question says, determine whether the Rolle's theorem can be applicable, and if it is applicable, find all the values of c in the open interval such that the derivative at that point is 0. So let's look at the first example. Fx equals x squared minus 1 over x in the interval minus 1 to 1. Clearly, the point 0, x equal to 0, lies in the interval from minus 1 to 1. And at this point, the function is not defined. And hence, my function is not continuous. So the very first condition of Rolle's theorem is not being applicable. Hence, we can say that the Rolle's theorem is not applicable. Let's look at another example. This is a quadratic function defined on the interval 0 to 3. So this quadratic function is given by minus x squared plus 3x. So before we can think about applying the Rolle's theorem, we have to verify those three conditions. As it is a parabola, which is a graph of a quadratic function, clearly it is continuous in the interval 0 to 3. It is also differentiable in the interval 0 to 3. We also know the differentiable of this function is minus 2x plus 3. Now the third condition, the value of the function at the endpoint 0, when you plug it over here, is 0. And the value of the function at the other endpoint 3 is again 0. So clearly the value of the function at the two endpoints 0 and 3 are the same. So by Rolle's theorem, this is applicable. Hence we can find a c in the interval 0 to 3 such that f prime of c is 0. So let's just solve this equation for fc. So when you put f prime of c to be 0, clearly you would just replace the derivative of this function, which was minus 2x plus 3, by a simple c. We get minus 2c plus 3 to be 0. Solving for c, we get the value to be 1.5. Hence, by Rolle's theorem, there exists a c which is equal to 1.5 in the interval 0 to 3, such that the derivative at that point is 0. Now we can also verify this by looking at the graph of the function, the original function minus x squared plus 3x. So this is, guys, the graph of the function minus x squared plus 3x. Notice at this point 1.5 and the value of the function, which is 2.25, clearly we can draw a horizontal tangent line. And this is an indication that the value of the function, the derivative of the value of this function at this point is 0. Now let's look at another example. Now this example is an example taken from trigonometry. Now here we will first check whether the function satisfies the conditions of Rolle's theorem. And if it does, then what are those points where the function has the derivative to be 0? So this function is a cosine function defined on the interval minus pi to pi. Clearly we know that cosine functions are continuous and differentiable. So clearly this function is continuous in the closed interval minus pi to pi, as well as it is differentiable in the interval minus pi to pi. Let's look at the value of the functions at the endpoint. Now, the value of the function at minus pi is minus 1. Similarly, the value of the function at pi is also minus 1. All the three conditions, guys, are satisfied for the Rolle's theorem. So, we can say by Rolle's theorem, there exists a point C in the open interval minus pi to pi such that f prime of C is 0. Let's find the derivative. So remember, your function is f of C here is cosine 2C. So when I take the derivative, it is negative 2 sine 2C equal to 0, or basically sine 2C is 0. Now we want to figure out what are the values where the sine function is 0. To do that, we are going to go ahead and look at the graph of this function sine 2C. To find where this function sine 2C is 0, we're basically going to look at the graph where the function is touching the x-axis. Remember, it has to be in the interval minus pi to pi. That's where we are going to be checking. So the minus pi to pi, notice, is here. So these values and these endpoints are not included, guys. So this is what we are basically looking at, the points in between this. So the graph, if you notice, is crossing the x-axis at the point minus pi half, 0, and pi half. So clearly, the value of this function sine 2C is 0 at the points 0, minus pi halves, and pi halves. So we've been able to find the value. So what we see is there are at least 3 points where the graph of the function is crossing the x-axis. Now there's another way to also check whether the values you are getting is right. We go back to the original graph. So when we go back to the original graph cosine 2x, we like to know the points where the graph has the derivative. Now remember, when we said the word derivative to be 0 for the original graph, in other words, we're looking at the points where the graph has a horizontal tangent line. That's the interpretation of it. So when we look at over here, notice the graph has, and it has to be in the interval minus pi to pi. Guys, keep in mind, the interval is very important. So we're looking at the points of the original graph from minus pi to pi. In other words, from minus pi to pi. This is where we're looking at. Let me just remove this now, so that we know where we're looking at. Here, minus pi to pi. So let's look at the graphs. Where do we find horizontal tangent lines? Because that's the depiction, the derivative is 0 over there. One is at minus pi half, the other it is at 0, and the third one is at pi halves. So they exactly are the same values which we are getting by applying the Rolle's theorem. Okay, now let's look at the mean value theorem. Now, the means value theorem states that if a function is continuous on a closed interval and a function is differentiable on the open interval a to b, then we will find a number c in the open interval a to b such that f prime of c is equal to f of b minus f of a divided by b minus a. We can look at also from the graphical point. Here's the graph. So clearly, here is our simple graph of a kind of a quadratic function here. And so we see it is a quadratic. So what we notice at the point A to B, even though the values are not the same, but there will be one point where the slope of the tangent line at C is the same as the derivative of that function. So let's go ahead, do some examples. Let's look at this example. Fx, which is given by 5 minus 4x, and we would like to find all the values on C in the interval 1 to 4, which satisfies the mean value theorem. Before we can apply the mean value theorem, we have to make sure that the conditions are met. Now there are two conditions, guys. One is continuity and the other is differentiability. Clearly, in the interval 1 to 4, very important, the interval is very important. The interval 1 to 4, this function fx is continuous as well as differentiable. Remember, the problem here is at 0 for this function fx 5 minus 4 over x. But this x is not given in our interval, so we do not have to worry. Now, so our conditions are satisfied for the mean value theorem. So according to it, there is a c in the open interval 1 to 4 such that f prime of c equals f of 4. Now remember, the theorem says f prime of c equals f of b minus f of a. Now b and a are the values of your endpoints of your interval. So my b over here is 4 and my a over here is 1. So I'm just plugging the values. So f prime of c is given by f of 4 minus f of 1 over 4 minus 1, which is basically 3 over 3, which is a 1. So let's find that value c where the derivative of this function equals 1. So when we solve it, now f prime of c, now remember what is my original function? My original function is 5 minus 4 over x. So if I take the derivative, it's clearly, so that it's a constant, it's a 0. Derivative of minus 4 over x is what? Minus 4, times minus x minus 2, which is the same as 4 over x squared. Remember, we can write this also as 5 minus 4x inverse. Okay, so f prime of x is 4 over x squared. And we come back and substitute the values here. So f prime of c, just replacing an x by a c, is 4 over c squared equals 1. Do the cross multiplication, you get c squared to be 4, or c is plus minus 2. Now remember, we're looking for the value which is in the interval 1 to 4, and only positive 2 fits that. Hence, we are able to find a value c, which is 2 over here, in the interval 1 to 4. Let's look at one more example. And we'd like to know whether the mean value theorem is applicable over here. Now the function is x plus 1 over x in the interval minus 1 to 2. The very first condition for mean value theorem is continuity. Clearly, the value of this function at 0 is not defined in this interval minus 1 to 2. Thus, the function is not continuous and hence mean value theorem is not applicable. Thank you guys. I will see you later.